guys, welcome to our day 5 of reviewing factoring, reviewing some important Algebra 1 concepts and getting ready for Algebra 2 next year. So far we've gone through graphing lines and slope. We did distribution. Yesterday we did factoring, specifically factoring with greatest common factor. And you're going to want to keep that in the back of your mind because today, if we look at our directions, we are factoring trinomials. And thinking about your prefix, tri means 3. You'll notice each of our factoring problems has 3 terms. And a term is really just, it has numbers, it has variables, right? It can be a mixture of both of them. So terms can be just plain numbers like 39, as well as 7x, x squared. They're separated by adding and subtracting, right? Addition and subtraction signs. So we're looking specifically at trinomials today, where the coefficient in front of your squared term, in front of a squared, x squared is a 1. That's what they mean over here by a is 1. It's a 1 in front of x squared. Remember, your general form for this looks like ax squared plus bx plus c. So we're just saying the coefficient in front of x squared is going to be a 1. And you've probably seen that written out before in Algebra 1. They use that standard format for quadratic formula and such. Now, the key thing that I'm trying to get at here, just doing a little bit of vocabulary introduction as we go through, is we're told to factor each of these. But some of them have a GCF that has to be factored out before you can do your regular factoring. So what you'll see is, looking at some cues, I'm noticing some of the ones towards the bottom don't have a 1x squared. They have a -2 or a 2 or a 3. So we probably are going to have to use that hint down there at those later problems, which is kind of nice. So let's just review basic how to factor a trinomial. For factoring a trinomial, your answer is going to be of this form. And you're going to have numbers here, and it might be adding the numbers, subtracting. This should look really familiar to you because this is looking like if I asked you to distribute, your answer would be this. And we're just going backwards. So distributing versus factoring are just inverse processes. They undo each other. So your question for yourself is what multiplies, so you've probably seen this before, to be 9, but what adds to be 10? And you're probably thinking, okay, well, 1 times 9 is 9, right? 1 times 9 is 9, but 1 plus 9 is 10. You're absolutely correct, and it will be a plus 9 and a plus 1. Now, to connect this back to our distribution idea, if I fill in my area model with what they gave us, x squared, I know the 9 has to go there. The question is, how do you fill in these? These are where you put your x terms, like 10x, right, is a term that has an x and a coefficient. And the question is, how do you fill it in? Let's say we know on the outside, you need something out here, right? You need those plane numbers. What's really useful about the plane numbers connects to that questions that we were asking ourselves here. When I say what multiplies to be 9, that's coming from these two numbers times each other equal 9. And what's also really cool, I'll use the yellow. When I say what adds to be 10, that's because if you look at where I highlighted yellow, when I put them in, it will be 9x's and 1x. 9 and 1 add to 10, but they also happen to multiply to be 9. So I just really want to connect to the fact that that's what you generally are asked to think through for these kind of factoring problems. Most of you guys probably just followed through because that's what you were told to do. But I just really want you to understand that that's why it works, that trick of what multiplies to be 9 but what adds to be 10. So just wanted to point that out, connecting back to our distribution idea. So let's look at this next one. And we'll do a couple more and then I'll have you do some for practice. So we'll probably do the first 3 and you'll do 4, 5, and 6 just to check how you're feeling. So this next one, what multiplies to be 9 but adds to be -6. And this one, because there's a negative, we're thinking that one might be a positive and one might be a negative, right? 9 is kind of an easier number. Generally, if it's a larger number, I will list out my factor pairs and think through which of the factor pairs could combine to be a 6. And I'm seeing 3 and 3. But in order to make it a -6, I would have to make them both -3s. And a negative times a negative is, in fact, a +9. So it's going to be, not x, sorry about that, a minus 3 times a minus 3. You can also write this as a minus 3 squared. So I'll just write out both ways to write that. Since we have the same thing times itself, it's like x times x is x squared. Okay? I'm going to do this next one, and this next one is going to be the last one we do together. And we're going to ask ourselves the same question. What multiplies to be -30, but what adds to be a 7? And this one's actually a much better problem. It's a little bit more interesting than before, because -30, you could have like -10 and 3, -5 and 6, -15 and 2, right? There's a lot more possibilities for this problem, which is really nice. And we're trying to find a pair that could combine to be a 7. So you really want to think about the difference of the numbers, right? Subtracting them, or you could be adding them. I'm saying 7 can come from a 10 and a 3, except for let's make it a +10 and a -3. So I'm going to just switch which one's positive, which one's negative. Okay, so a 10 and a -3 would add to -7. 10 and a -3 would multiply to be -30. So I'm going to make it x plus 10 and x minus 3. And we're all set. Okay, guys, you have 3 practice problems to do on your own. Try them out, see how you're feeling. Afterwards, we'll look at some more complex problems where we, in addition, have a greatest common factor that we have to adjust first. Okay, so work through these only on pause once you've tried them on your own. I'll talk to you guys soon. Okay, guys, here are your worked out solutions for your 3 practice problems. So take a look at them and make sure that you're feeling good. Feel free to pause the video if you need to double check. Notice number 6 I wrote in 2 different ways because you have x plus 1 times x plus 1. You could also write that as x plus 1 squared. That would be, I would say, the most simplified form that you could write it, and probably preferable, but either are correct. So you are not incorrect by leaving it the first way. Now these are problems where we don't see a 1 in front of x squared. And also that negative sign there would also be a good example because you have like a -1 in front of x squared, right? These are problems where we first have to do a GCF. So maybe I'll make a little separation. And so step 1 is going to be we factor out a GCF. And step 2 is we factor our trinomials, just like we did previously. So generally when we do factoring problems, I like to remind my students in Algebra 2 that our first step is always double check, do we have a GCF? That should always be the first thing that you check because it can drastically make a problem simpler and make it easier. So let's look at this first one. The first one, we want to make it turn into just like plain x squared. So you would probably infer that you want to take out the -2 as your GCF. So I'm going to make a note GCF. And the other thing to be noticing is if we look at the -2, the 14, and the -24, right, they're all even numbers. So that's another cue that we should be able to pull out a GCF. So -2 times x squared would make -2x squared. Remember, you can distribute if you want to double check that it looks correct. -2 times what is going to give us that 14x? We would need a -7x, right? Because the 2 negatives will make a positive. And -2 times what is going to be -24? That'd be a +12, because a +12 times a -2 would make that -24. Okay, so now we've done like first step, and we're done with that step. The next step is to focus on just this yellow bit here. We're going to have to keep that -2 in front. We want to focus on, can I factor what's left? And I'm going to try and color code it there so you can see it more easily. And to factor this bit, we're going to have to ask ourselves the same thing as normal. We're going to have to ask ourselves what multiplies to be 12, but what adds to be -7. And for 12, you're probably thinking of that 3 and 4. That's generally pretty common, but we'll make them both negative. So it's going to be x minus 3, x minus 4, because those multiply to be two negatives make a positive 12, and the two negatives combine to be a -7 when you add them. Okay, so really these problems just have one extra layer added onto them than previously. Okay. I'm going to do number 8, and then what I'm going to suggest is you guys try number 9 and 10 for practice. Notice each time we're really looking at that coefficient, the number in front of the x squared term, to indicate what we should be pulling out. Number 8's a little tricky though. If we want to just get it to be a squared, right, instead of an x squared, same idea. We need to get rid of two things. We need to get rid of that 2, and we also don't want that b, right? We want just something squared. X squared, a squared, w squared. You guys are probably more used to seeing an x squared. Some students prefer, for a problem like this, they'll just take the x and replace the a's with x's. If you prefer, you could totally do that. Some of my students are just a little bit more comfortable seeing an x rather than an a. So feel free to do that if you feel that that helps you. Okay. And then to get a 2 to become a -10, we need a -5. The x is going to, oops, I'm looking at the x now, not the a. The a was already there, and -5a times 2b would be -10ab. So that looks good. And then 2 times what is going to be 8? We need a 4. And the b will get there if we were to distribute, right? Okay, so we've done our GCF work. Now we need to focus in on here and factor this just like normal. Okay, so I'm going to rewrite that with my 2b. That's my GCF right there, GCF, I'll label it. And then I need to factor just like normal. So I need what multiplies to be 4, but what adds to be -5. And you're probably thinking 4 times 1 is 4, but 4 plus 1 is 5. You're absolutely right. We just want to make those negatives. So -1, -4. And I'll fill those in. -1, -4. And that's replacing that yellow bit. Generally for factoring problems, like I said, you want to start with the GCF. And at the end, you always double check, can I go any further? And of course, each piece of this, like a minus 4, a minus 1, you cannot go further. Sometimes in Algebra 2, you'll see some more complex factoring problems where you'll be able to keep going, and it's kind of like peeling a layer after layer. Okay, now I want you guys to try number 9 and number 10 for extra practice. I'm going to pause the video and work it out. I want you to pause the video so you can try them on your own before checking your answer. Okay guys, here are your answers. Number 9 was probably a little bit easier for you guys. Number 10 might have given you a little bit more trouble. The tricky thing about number 10 is that your greatest common factor is just actually a -1. It's not like -2 or -3, and it's a little harder to see. Now notice if I was to distribute that -1 into the x squared minus 4x minus 12, right? Because distributing is your way to double check if you factored right. You would get -x squared plus 4x, right, because there's 2 negatives making a positive. And then again, plus 12, because 2 negatives, the -1 and the -12 would make that positive 12. So that's always a way you can double check if you have factored correctly. From there, you need to ask yourself the question, what multiplies, write it out, to be -12, but what adds to be -4? That one's a little trickier, and it's actually a -6 and a +2. Generally, the problems where the number's negative are a little harder to think through. It's a little bit easier for problems like number 9, where it was a +9 and a +1. So that's it for today. We have finished reviewing factoring trinomials, specifically where our coefficient, like up above, was 1, right? The coefficient of x squared, a squared, except for some examples down here where we had to first do a factoring out of a GCF before we could factor our trinomials like regular. Okay guys, I will see you tomorrow for some more factoring fun. Have a good night.